Here we have a ring as shown in this figure. Initially at rest, we should find velocity of this ring after L distance. So as usual, we need to draw a free body diagram. mg, tension, normal force, and the friction force upward. Friction force. And we know that it will move in this direction. In this direction we have a acceleration. So basically Newton's second law in this direction will be equal to mg sine alpha minus tension minus friction force equal to ma. Very simple. Newton's second law in vertical direction, basically in this direction, let it be y, this direction let it be x. We know that it is not moving in y direction, so normal force will be equal to mg cosine alpha. Now let's come to friction force. Here at this point we have a sliding because this ring is rotating in this direction. It can rotate only in this direction, otherwise it cannot move because we have a rope here. So if it moves in anti-clockwise, this point, it means sliding. If it's sliding, friction force already reached its maximum value. It means friction force already reached its maximum value. It means we can use this equation, coefficient of friction times normal force or mu mg cosine alpha. So let's use these equations, what we can get. So here let me substitute friction force into the first equation. So mg sine alpha minus tension minus mu mg cosine alpha equal to ma. So here we have unknown tension, unknown acceleration, and we have only one equation. So now let me draw my ring like this. Let me draw again forces acting on this ring so we could study it better. So in this direction we have a friction force. In this direction we have a tension. Only these two forces can rotate this ring. mg cannot rotate it because it's passing through its center. Normal force also cannot rotate it because it's also passing through its center. That's why it cannot rotate. Only two forces can rotate it, tension and friction force. So friction force creates torque, it's clockwise direction, and the tension creates torque in anti-clockwise direction. Friction force's torque is greater than torque of the tension. That's why it's this ring, vice versa. Torque of the tension is greater than torque of the friction. That's why this ring is rotating in anti-clockwise direction. So let's write torque for the ring. Tension times R minus friction force times R should be equal to moment of inertia times acceleration, angular acceleration, sorry. TR minus friction force times R equal to ring inertia, moment of inertia for ring is mr square times angular acceleration. So we can cancel one of the radiuses. So T minus friction force equal to mr alpha. And this angular acceleration equal to A over R because there is no sliding at this point. Basically this part is rotating with constant acceleration. So tension minus friction force equal to mr times A over R. Basically we have a tension minus mu mg cosine alpha equal to ma. MA. So from here tension equal to mu mg cosine alpha plus MA. This is our main second equation, and we can substitute into the first equation. So we can continue. Mg sine alpha minus tension, which is mu mg cosine alpha minus Ma minus mu mg cosine alpha equal to Ma. We can take Ma to this side. Here we have a mg cosine. So basically 2 mu mg cosine alpha equal to 2 Ma. We can cancel masses. So acceleration equal to g sine alpha minus 2 mu cosine alpha over 2. Or we can say g over 2 sine alpha minus 2 mu cosine alpha. So this is the acceleration of the ring.